Welcome. Today we want to talk about further logarithms, but before we do so, I want to let us remind ourselves on the rules of indices, because the rules of indices and the logarithms, they are actually married to one another. They work hand in hand. So when we have a number written as a raised to power m times a raised to power n, this a is the base and m is the index. So when indexes are men, we call them indices. So the index, the plural, is indices. So a times a, the base is the same, and it is multiplied. What do? We take one base, that is a, and then we add the index or the power. This one is the index or the power. We add. I've given an example here. 2 raised to power 5 times 2 raised to power 3. The base is the same. We write the base 2, and then the power we add 5 plus 3. The answer is 8, and that is row number 1. Row number 2 is division. When we have indices like this, a divided by a, the bases are the same. When it is a division, what do? We write one base and then subtract the powers. Therefore, m minus n. That one gives us the answer. Therefore, 5 raised to power 7 divided by 5 raised to power 3, the base is 5. So we take one base, and then what do we do with the power? We subtract them. 7 minus 3, the answer is 4. When we have a number raised to a power and then raised to another power, what do we do with those power? We multiply the powers. So power m times n will give us a m n. A raised to power m n. So a times m n. For example, we have 10 raised to power 3, then bracket raised to power 7. So what you simply do, multiply the powers. 7 times 3, which is 21. Very fine. Any number raised to power 1 is equal to that number. You should know 17 raised to power 1 is equal to 17. So 17 raised to power 1 are equal to 17. It's the same thing. A number raised to power 0 is always equal to 1. A number raised to power 0 is equal to 1. A divided by b raised to power m simply means a raised to power m divided by b raised to power m. That's what it means. If we have a number like this, 5 divided by 6, that's 5 over 6, it's a fraction, raised to power 2, it means 5 square, 6 square, and this is the answer here. A raised to power negative m. So the index here is negative. So to put this index to be a positive, you introduce a reciprocal. So 1 over a raised to power m. Now this one is the same as this. For example, when we have 8 raised to power negative 2, it is exactly equal to 1 divided by 8 raised to power 2 positive, which is equal to 1 over 64. Lastly, but not least, when we have a raised to power x over y, the power here is a fraction now. The power is a fraction. So this one is the same as the square root of the denominator, and then the base times the power times the numerator of the power. For example, we have 49 raised to power a half. That simply tells you to find the square root of 49 and then times 1. So a number times 1 is that number. So times 1, a number 7 raised to power 1 is 1. Another example is 27 raised to power 2 over 3. The power here is 2 over 3. So 27 raised to power 2 over 3. So 3 the denominator. So it means we find the cube root of 27. And then the power 2 we multiply by 2. The cube root of 27 is 3. 3 square is 9. So once you have this in mind, now we will jump into further logarithms, because they are interrelated. when a number is written as b raised to power 2 equal to c, b raised to power 2 equal to c, this number is called the base. This number is the power, the index, and actually this one is the answer for this. For example, we have 2 raised to power 5, the answer is 32, right? So 2 raised to power 5, the answer is 32. 5 raised to power 2, the answer is 25. So that one we know. So when we represent a number like it is, this one we call it the index notation. It is called the index notation. We can write this number in the logarithmic notation. We can similarly we can write this number in logarithmic notation. So when we are writing, we're converting index notation to logarithmic notation. This is what I want you to be very keen on. So we have 5 raised to power 2 equal to 25. This is the base. I've said that. This is the index or the power, and this one is the answer. So we want to write this one in logarithm. So we write log base. The base here is 5, and then the answer 25 equal to 2 the power. So now we have converted the index notation to logarithmic notation. This one is very important for us to go to deal with further logarithms. It is important that you understand this. Therefore, we continue. Let me write one more example. We have 3 raised to power 2. The answer is 9. That's very true that 3 square is 9. Very right. So here 3 is the base, the power 3 square, this is the power, and the answer is here. Therefore, when you are writing in a logarithm notation, you introduce log, right? The base is 3, and then the answer is 9, like this. Now this one, how do we read number? How do we read this number? We read this number as the logarithm of 9 to base 3 equal to 2. Once again, the logarithm of 9 to base 3 is 2. That's how we read this number. Log 10, when a log is just written like this, the base is always 10, because our mathematical table and the calculator, the log is to base 10. So when it is written as this, it simply means log base 10, 10. That's what it means. When we have a log to base 10 and 10, or 2, 2, that one is simply 1. Right? When you take your calculator, you will find that it is true. So we are saying that the log of a and then a, the answer is 1. Very important. It means that log to base 2, 2, the answer is 1. So whenever you see a logarithm, the base is the same, a logarithm 3 and then it is 3, you should always remember that that one is 1. So that takes us to laws of logarithms. So we want to look at laws of logarithms. Log a xy, this is multiplication, this is x times y. The logarithm of a, the logarithm of xy to base a is the same as, because remember, when we multiply in indices, we mean addition. So this means that log a of x plus log of a y. That's what it means. So log of a, log of xy to base a is the same as log of x base a plus log of y base a. Very important to note. For example, I can give an example that the log of 3 or of 10, log of 10, log to base 10 log to base 10 3 times 2, right? This is the same as log to base 10 3 plus log to base 10 2. Simply we know this one is the same as log to base 10 6, which is the same as log of 10 3 plus log 10 2. When you place the calculator, it will show you that the answer is the same. That is row 1. Row number 2, the log of a base a, log base a, x divided by y. This is a fraction, so we have a log and then x divided by y. This is simply the same as the log of base a, x, the numerator, divided by log base a, y. That's what it means. Sorry, not divided by, but minus. This is a division, so we subtract. So let me give an example. So we have log base 10 5 divided by 4. This one is the same. Log to base 10 5 minus log to base 10 4. It is the same thing. So that's why I told you need to understand the row of indices, and it will help us when we have division with mean subtraction. When we have multiplication, it is the same as we have addition. Very important. Log a is the base, x raised to power n is equal to, now this power here, we have n log a base a and then x. So I'm saying that the log to base 10 x raised to power n will be the same as n log x to base a. Let me take an example so that you can be able to see clearly. So if I have log to base 10 5 raised to power 2, right? So this one is the same. This to a power here, you put it here. So we have 2 log base 10 to 5. Very important, very important. So if you have 2 log base 2 4, right? What does that mean? This simply means that it is a log to base 2 4 squared. Any number that comes before the log is the square of this number. A number which comes before the log, the word log, is the square of the given number. You should know that. We give an example here. Log a square divided by b cube. This one is the same as the log a square division, that is minus log log b cube. That's what it means. But we have said that this one is the power, therefore it means that 2 log a minus 3 log b. When a log doesn't have a base, the obvious base that is there is base 10. You should know that. Number 4, log of a to base b will be equal to the reciprocal of log a b. Let me give a practical example. If we have log to base 3 2, similarly we can write the same thing using this notation, that 1 the reciprocal of log, instead of 3 the base, now we have base 2 and then 3. This one and this one is the same thing. Very important to note, because sometimes you need this to know this. There are some problems that need you to understand this so that you can be able to solve them. Example, simplify without using tables. Log 25, this is the base 10, plus log base 10, 625 to base 10, and this. So how do we go about this? First, you need to see that this one, we can write this number in a different way. So how else can we write this? We can write this number as log 5 square, right? Plus log 5 raised to power 4, we divide by log 5. We have said that whenever you see a number written like this, it is simply you bring it to here. This is 2 log 5 plus 4 log 5. We divide by log 5. Now, since the log is to base the same and it is log 5, so the base is the same, we can even ignore you can ignore because it is like 1 divided by 1, so it is the same, the base is the same. So this one, ignore the base. We have 2 plus 6, right? And that one will give us, so plus 4 will give us 6. So the answer there is 6, because the base is the same. Or from here, we know this is 2 log 5, 4 log 5. It's like 2m plus 4m. What do you get? 6m. So we will have 6 log 5 divided by log 5. So log and log cancels and the answer is 6. So you should know that. Example 2, log 2 plus log base 3 log 3 base 2 plus log y base 2 equal to log 5 log base 2 plus 1. So first, let us, you like terms together. There is 1 here, there is 2 here. So you bring this one here and you subtract. So we will have 2 minus 1 plus log 2 base 2 3 plus log 2 y equal to log 2 5. The answer here is going to be 1 plus log 2 3 plus log 2y equal to log 2 5. But what do you understand by log 1? Log 1, the base here is 2. It means it is log 2 2 plus log 2 3 plus log 2y equal to log 2 5. That is what it means. Now you can see the log is the same. So we are going to have, so what you need to do, ignore the log because the logarithm is the same. When you do that, you should remember the row of indices. That now this is addition, it's going to be multiplication. So 2, when we ignore the logarithm, the base, it is the same. So we are going to have 2 times 3 times y, and the answer is 5. You should see that. So now we are going to have 6y will be equal to 5. And then we want the value of y, we divide by 6, divide by 6. So y is equal to 5 over 6. Like that. Without using a table, example 3, calculate, or calculator, evaluate log 20 to base 10 plus log 40 base 10 minus log 8 base 10. You can see the log is the same. So when the log is the same, that is very easy. So this one means that because the log is the same, we can say log 2 base 10 into log, this is 20, and it is addition, it means multiplication, 40. This is minus, remember, means division, so divided by 8. The log, this log stands for everything, log 20, log 40, log 8. So from there, now you cancel this once here, this cancels out here, what? 5. Now we have log 100 to base 10. What is that? That is 2. Yes, you should know that. It means the base is 10. So which number will you raise to power the base to give you 100? It is 2. So this one is actually, you ask yourself, the base is 10 and the answer is 100. Which number will I raise with 10 to give me this? It is 2. And that one gives you the answer. So first, look at the equation, the way it is written, and then you can realize that this is 2 log. I said when a number comes before the log, you should know that is the power of that logarithm. So this one means it is log to base 10, 25 square, which is actually 625, log 8 raised to power 2, which is 64, plus log base 10, 4 raised to power 5. So once you have, you should know now the log the base is the same, so that is log to base 10 into 625. This is subtraction, so it's going to be divided by 64, and then times 4 raised to power 5, that is 1024, right? So this one is going to give us log to base 10, 10,000. Which number will you raise to base 10 to give you 10,000? The answer is 4. Thank you for learning with us. We really appreciate you. Thank you very much.